Good morning. So as I mentioned, by looking at the notes now instead of in class, it will give you time in class to be working on your assignment and getting questions answered, because some of these can be a little bit tricky. And taking notes is really mindless. You don't need to have people there to ask questions. We're using it this way. This has actually worked really well with my Algebra 2 classes this year. So we're going to try it out. So we're going to look at derivatives. Today we're looking at the product and quotient rules. So we're going to have things multiplied together and things divided, and we're going to see how we can take derivatives of that. So we'll start out with the product rule. And the product rule is when we have two functions multiplied, f of x times g of x. An example, if y equals x squared times sine x. That's two things multiplied. X squared is f of x, sine x is g of x. Now, the product rule, I'm just going to give it to you. If you really want me to, I can show you why it works in class. It's kind of weird. There's a couple of really weird steps there. But if you really want me to, I will show you. Anyway, the product rule says that if we have these two things multiplied, then the derivative, we take the derivative of the first thing times the second thing plus the derivative of the second thing times the first thing. Or in a more simple way, because we have lots of x's and stuff, if it equals uv, it's u dv, that would be the derivative of v, plus v du. And this way of looking at it is going to lend itself to how we're going to actually look at this and do this. We're going to figure out what these pieces are, find the derivatives, and then we just plug it into the formula. So looking at this question we have right now, y equals x squared sine x, we need to figure out what is u, v, and then take the derivatives of each of those. So u is just x squared, and v is sine x. The derivative of x squared, 2x, and the derivative of sine of x is cosine of x. And now we're simply going to multiply these two plus multiply those two. So y prime is going to be 2x sine x plus x squared cosine x. So when you look at it like this, I don't think it's anywhere near as scary as when you just look at the equation. It's just this times this, plus this times this, and then you're done. Sometimes there's a little bit of simplification that can go on, but it doesn't have to happen. Here, yeah, you could factor out an x. It's not going to do you any good. Don't bother. So let's look at another one. F of x equals x to the fifth times tangent of 3x. And so we're going to need our u, v, du, and dv. U is x to the fifth, v, tangent of 3x. And being that it's multiplication, and multiplication is commutative, you could switch those two around if you want as well. The derivative of u is 5x to the fourth, just a basic power rule problem. And the derivative of v, we're going to have, this is a chain rule, because we have tangent of something. The derivative of tangent is going to be secant squared of 3x times the derivative of 3x. The derivative of 3x is just 3. So we have 3 times secant squared of 3x. And now plug it into the formula. We're going to have that times that plus that times that. So f prime of x will equal 5x to the fourth times tangent 3x plus x to the fifth times 3 secant squared 3x, which I like putting that 3 out in front, just habit and all. So that's the basic idea of the product rule. Try these couple questions, and then we'll go over them. So the first one, f of x equals x cubed cosine x. That's going to be almost identical to this one. Second one, y equals 3x plus 2 secant x. Gonna have to remember what the derivative of secant is. And one last one, f of x equals x squared plus 3x times 4x minus 7 cubed. Now, is it possible to multiply this out to get a big polynomial? Yes, it is. You'd have to cube this and then multiply by that. It would be very obnoxious. You don't want to do that. Use the product rule. There's something here times something here, which will include chain rule. So pause this, try these questions, and then when you're ready, go ahead and push play. If you just want to do one of them at a time, that'll work. We're going to go over these one at a time. But make sure you have a paper and pencil, which you should have because you should be taking notes on this. I would definitely have this stuff written down. But get out a paper and pencil. If you don't, work these problems and then push play when you're done. Welcome back. Did you do it? No, you actually have to go back and try these problems, at least one of them in the beginning. If you need to, push pause again. All right, well, if you're not doing it, it's your own loss. Participate in your own education. So, looking at the first one, we need our v. U is x cubed. V is cosine x. Derivative of x cubed, 3x squared. Derivative of cosine x, negative sine x. We just need to take the products and add them. 3x squared cosine x plus negative, so that would be minus x cubed sine x. And that's it. So did you get that one right? Yes? Excellent. No? Do you see where you went wrong? Do you need to perhaps go back and fix the next one? Or if you only did this one, pause it and do the next one. See if you can get it. And if you're ready to go on, we can go on. So we need our u and v. U is just this first piece, 3x plus 2. V is secant x. The derivative of u, the derivative of 3x plus 2, is just 3. And the derivative of secant x is secant x tangent x. Take our take the products of these guys. 3 times secant x plus 3x plus 2 times secant x tangent x. And notice when I'm multiplying these, I'm always doing these two first plus these two. In this case, it does not matter because it's commutative. But with the quotient rule, which is going to be very, very similar, it will make a difference. And so it's good to just get in the habit to do this times this, and then this times this. All right, ready for the third one? We need our u's and v's. U is just x squared plus 3x. V is this 4x minus 7 cubed. The derivative of x squared plus 3x is 2x plus 3. And the derivative of this, we're going to have 3 times the 4x minus 7 squared, and then times the derivative of the 4x minus 7, which would be times 4. I would simplify this. 3 times 4 is just 12. Then we do our multiplications. There it is. So it's just 12. And so I multiply it by this one. So 2x plus 3 times 4x minus 7 cubed plus 12 times 4x minus 7 squared times x squared plus 3x. And it gets long. These answers aren't necessarily going to be pretty answers, but that's what they are. This one got pretty long, and they can get longer than this too, depending on what it is. This is just the beginning. And so, but that's product rule. It looks big and complicated, but if we break it down into its pieces, just plug it into the formula, and it works a lot nicer. The quotient rule is fairly similar, except instead of two things being multiplied, we're looking at f of x divided by g of x. So something like sine of x over x. Now, I didn't show you how the product rule comes about, because that's using the limit definition, and it's pretty in-depth. But if we trust that that's true, we can use that to help show the quotient rule, which I think is going to be a little bit more valuable. So let's look through that real quick. If we have just y equals u over v, we're going to use u and v again, just like product rules, so we'll start with u and v. The first thing I would do is rewrite this. V is in the denominator, so we could write it as u times v to the negative 1. This is now just a product rule question, so we can use the product rule. If we use u and v, we're already using u and v. That gets confusing, so I'm just going to change those to a and b. A equals u, b is v to the negative 1. dA, the derivative of u, is just du. It's the derivative of u. And then the derivative of b, well, this is chain rule. We have negative 1 times v to the negative 2 times the derivative of v. So negative v to the negative 2 times dv. Now we can multiply v to the negative 1 du plus negative uv to the negative 2 dv. So the plus negative makes minus. So that's just product rule. Next, we can rewrite our v's as positive exponents in the denominator. So this could be du over v minus u dv over v squared. Well, this is almost common denominators. Let's multiply this one by v, which means we need to multiply the top by v. So we have v du over v squared minus u dv over v squared. We can combine those into a common denominator, v du minus u dv over v squared. So that would be this minus this over the denominator squared. So that's quotient rule. If we have our function notation f of x over g of x, then we have f prime times g of x, the derivative of the top over the bottom, or times the bottom, minus the derivative of the bottom times the top, divided by the bottom squared. One of the big deals is remembering which one goes first, because the negative makes a difference. The negative comes from the derivative of the bottom. It comes from that negative 1 exponent. So that's one way I remember that. Or if it's u over v, it's just what we have. v du minus u dv over v squared. There's a poem that I remember from way back when I was learning this. Isaac Newton taught me personally. It was right after he was finished inventing this. And he said in his quite funny accent, so instead of v and du and u and dv, he just used high for the top, u, and low for the bottom, the denominator, v. It's low d high minus high d low, square the bottom, and away we go. And the rhyme helps to remember which one goes there. Anyway, let's look at the one we have, sine of x over x. So we need our u's and v's. U is the numerator, sine x. V is the denominator, x. The derivative of sine of x is cosine x. The derivative of x is 1. Now we're going to multiply cosine x times x and 1 times sine x. And so cosine x times x minus 1 times sine x over x squared, the denominator squared. And that's it. That's quotient rule. It's very similar to product rule. It's just a slightly different formula. So let's look at another one. Let's look at tangent x. Well, that's not a quotient, but it is, Because what is tangent? Tangent is sine over cosine. And so now we can see why these trig functions are what they are. You don't have to just memorize it because Mr. Swanson told me that's what it is. You can find them. So we can get our u's and v's. The u is sine x. The v is cosine x. The derivative of sine is cosine. Derivative of cosine is negative sine. You can multiply. Cosine times cosine is cosine squared minus negative, so it'll be plus sine squared all over cosine squared. Well, I remember the derivative of tangent is secant squared. This isn't secant squared yet. We have sine squared plus cosine squared. Think back to our trig chapter. What is sine squared plus cosine squared? If you're thinking, hey, that's the Pythagorean identity and that equals 1, then you would be correct. And then 1 over cosine squared, 1 over cosine is secant, so 1 over cosine squared is secant squared. And that's why the derivative of tangent is secant squared. The other three work out basically the exact same way. And those are actually in the assignment. So, but before, almost done. Before we're done though, let's try one just to make sure that you can have an idea what you're doing. Try y equals x squared over cosine x. Get your u's and v's. Go ahead, pause this, and come back when you're done. How do you think you did? Did you follow this mostly? So, u's and v's. U is x squared. V, cosine x. So du is 2x. dv is negative sine x. You can multiply, and subtract them. So 2x cosine x minus negative, so that'll be plus x squared sine x all over cosine x squared, or cosine squared of x. You could put that in parentheses squared, or you could put the squared here. And so that is the quotient rule. I hope you enjoyed this. You have it. You can rewatch it. You can rewind. You can see, remember that example. Again, it's worked out really well. It's a very good resource, and it will free up a ton of time in class so that you can work on problems and get questions answered. So I will see you in class ready to work.